Okay, now we discuss about the electrolysis process. Okay, so in the electrolysis process, we take an electrolyte. Means, for example, if you are going to do uh, the electrolysis process for sodium chloride solution, so that will be treated as an electrolyte. Means the solution we are taking, in the purpose of passing electricity, that is called electrolyte or electrolytic solution. Like the vessel, the apparatus, there is a different type of apparatus are there. So the apparatus used for this electrolysis purpose are known as electrolytic cells. As in any electrolytic cells, we took the electrolyte and we pass the electricity with the help of the battery. The one rod is connected to the positive terminal, which is known as anode. The other rod is connected to the negative terminal of the battery, that we treated as cathode. So in any electrolyte, on passing of electricity, there is a formation of, at first, ionization takes place. So what do you mean by ionization? Ionization means forming ions. Here any electrolyte forms ions. Actually, the electrolyte means which is able to form ions. Ion form that is called as electrolyte. Electrolyte and the passage of electricity, it is ionized, forming ions. We know the ions. There is formation of anions, are negative charged, and there is a formation of cations, which are positively charged. And in the passage of electricity, at first there is a formation of anions and cations takes place. These cations are itself positively charged. Therefore, they move towards the anode, they move towards the anions. Cations itself positive charge. They move towards the negative charge. Negative charge means cathode. So simply we can say cations move towards cathode. Means general cation charge is positive. That's why they go towards negative sides. Cations, cathode. And whereas anions itself negatively charged. Negative charge means they are attracted by the positive side. They goes towards anode. Anode means connected to the positive. Means cations goes towards cathode, anion goes towards anode. Here, cations undergoes reduction reaction. So we should remember always that cation goes towards cathode and this cation undergoes reduction only. This anions goes towards anode and undergoes oxidation. This total phenomena is called electrolysis. By passing of electricity through an electrolyte, formation of ions takes place, cation and anions. Cations goes towards cathode, undergoes reduction, and anions goes towards anode, undergoes oxidation, and forming a different type of products at anode and cathode. This total phenomenon is called electrolysis. Now we see about the products which are formed at different electrodes. That is the main important point in this electrolysis. Okay, now we see the products formed in the electrolysis of molten or nothing but fused NaCl. Here molten NaCl means which consists of only NaCl. There is no presence of any other ions. It contains only NaCl. Okay. Now we see the first in the electrolysis of molten NaCl. At first we will get ionization, Na plus Cl minus, and at cathode, the cation goes towards cathode. The cation involves, we know the cation at cathode, the reduction reaction takes place. Okay, mean the product formed at cathode is sodium. Next, what takes place at anode? The Cl minus or the Cl minus. So then the anions undergoes oxidation, so the releases electron plus Cl2. So for the balancing purpose we are writing oxCl2, or by taking 2 electron we can write Cl2. Okay, means the products formed in the electrolysis of molten NaCl is at cathode sodium and at anode chlorine. Okay, let's see the second one. The electrolysis of potassium bromide. So it's a fused one. There is no doubts in the molten and nothing but fused states. Okay, it undergoes at first ionization. So these cations undergoes and forms K at cathode. It forms potassium at cathode. The Br minus as anion goes towards anode and forming losing electron, and Br2 at anode. Okay, these are the products formed at different electrodes in the electrolysis of fused nothing but molten compounds. It is simply we can, by seeing the compound we are able to write the products. So now we see the electrolysis of some aqueous compounds. For molten there is no specific discussions on that, but in the terms of aqueous NaCl or any aqueous compound, we need to give some explanation for this compounds. First we see about aqueous NaCl. So in aqueous NaCl, by passing electricity, it forms ions. So Na plus Cl minus. Aqueous means it also having water content. So there is also presence of H plus and OH minus. Now the thing is, here two cations are present. The cations present in it Na plus and H plus. So we know that at cathode, which reaction takes place? At cathode, reduction of this cation takes place. Means here there is two ions are present. This is normal metal ion. This is H plus ions. So which undergoes the reduction process. So at the same time both cannot undergoes reduction. Only at a time, at first only one undergoes the reduction. So now we need to know whether Na plus undergoes reduction or H plus undergoes reduction. So it depends on their discharge potential. Discharge potential means they are involving reduction or they are involving oxidation. So oxidation involve aina, reduction involve aina, దాంట్లో ఉన్న చార్జ్ పై ఒక ప్రోడక్ట్ ఫామ్ అవుతుంది. సో కాబట్టి దాన్ని డిశ్చార్జ్ పొటెన్షియల్ అంటాం. డిశ్చార్జ్ పొటెన్షియల్ బేస్ చేసుకొని ఏది ఫస్ట్ రియాక్ట్ అవుతుందో సో దాన్ని యూజ్ చేస్తాం. సో అకార్డింగ్ టు ద డిశ్చార్జ్ సిరీస్, ఇట్లా పాజిటివ్ అయాన్స్ వచ్చినప్పుడు వీ నీడ్ టు రిమెంబర్ దట్ ద 1A గ్రూప్ అయాన్స్, 2A గ్రూప్ అయాన్స్, 1A group ions, 2A group metal ions, aluminium, zinc related ions. ఈ ions కాంపిటీషన్ లో H plus వచ్చింది అనుకోండి, then there is a reduction of H plus takes place. Reduction of H plus takes place. Okay. In the presence of metal, 1A group metal ions, 2A group metal ions, or aluminium ion, zinc ion, ferrous ions, the reduction of H plus takes place. The reduction of these ions does not take place. Means here the competition between the Na plus H plus for reduction, it belongs to 1A. So actually this sentence is based on their reactivity series, nothing but their discharge potential values. Now the H plus electron, it becomes half H2. Okay. So there is no formation of sodium takes place. After the total completion of the H plus, there is a possibility of the formation of Na. But normally we write the product formed at the cathode is hydrogen. So what about anode? So which anions are present in it? The anions are present in it are Cl minus and OH minus. Here again there is a combination between Cl minus and OH minus. Here important we need to remember some ions, F minus, fluoride, nitrate, sulfate, phosphate. Only these four are the exceptions. In the presence of these ions, OH minus undergoes oxidation. OH minus involves oxidation. Means in the presence of OH minus, this F minus, NO3 minus, SO4 minus, PO4 minus, only four are there. We simply remember easily. These ions does not undergo oxidation. In the place of this, OH minus undergoes oxidation and releases H2O and oxygen. But now here there is no problem. It is not in these accepted ions. So this is OH minus are not involved. Cl minus involved in the reaction. Cl minus, it undergoes oxidation. And there is this balancing purpose we are writing half. Means in the aqueous NaCl electrolysis we will get in the aqueous electrolysis we get at cathode we will get hydrogen, at anode we will get chlorine gases. Now we see the similarity for KBr. So for KBr it is the same. At first it is ionized to K plus Br minus, and there is a presence of water content, undergoes H plus OH minus, and at cathode there is a possibility of reduction of K plus and H plus. We know that in the place of 1A cannot undergoes reduction process. In the place of this 1 ion, H plus undergoes oxidation. So H plus undergoes reduction, forming hydrogen. So we need to remember that 1A group, 2A group, aluminum, zinc, ferrous ions are there. They do not undergo reduction process in the presence of H plus. Again there is a combination between Br minus and OH minus. So Br minus is not in the exceptional list, so it undergoes oxidation. There is a formation of H2 at cathode and Br2 at anode. So we need to just remember this about cations and exceptional anions. Okay. Now see the electrolysis of other ions, the aqueous copper sulfate and aqueous silver nitrate. So here, first we see this. The copper sulfate ionized to Cu plus 2, SO4 minus 2, and the result of water content is H plus and OH minus. Here there is a combination between H plus and Cu plus 2. So it is not belongs to 1A group, 2A group, aluminum, zinc, ferrous. It is not in the exceptional case. So it undergoes the reduction than this. Therefore, at cathode, Cu plus 2 undergoes reduction, forming copper. Next, what about anode? At anode, which reaction takes place? Again, there is a combination between OH minus and SO4 minus 2. Just now we see, we discussed that sulfate is in the exception ion. Sulfate does not undergoes oxidation in the presence of OH minus. So at this case, OH minus undergoes oxidation. So that is like this. There is a formation of oxygen gas takes place and copper takes place. At cathode, copper takes place. At anode, oxygen takes place. In the same way, in the silver nitrate, the ions are Ag plus and NO3 minus. and from water there is a presence of H plus and OH minus. H plus, Ag plus. In this combination only Ag plus undergoes reaction. We know the exceptional cases here. So no H plus, Ag plus electrons forming Ag. And we know that NO3 minus OH minus, NO3 is under the exceptional cases. It is not undergoing oxidation. OH minus undergoes oxidation. The OH minus on oxidation mainly releases oxygen gas. Means in this AgNO3 the silver is formed at cathode. In the place of NO3 the oxygen is released at anode. Okay, now we see the third mode of electrolysis processes.